Hi there everybody, this is Chris Schmidt with another full Grayscale Gorilla tutorial, so let's jump right on in. So, what are we going to talk about today? We are going to talk about X-particle avoidance. So this is a technique I came up with. I actually came up with this years ago when I was playing with thinking particles, and I was super curious if it would translate into X-particles, and it did wonderfully. Way better than I could have thought it would. So we're not going to try and make anything specific here. We're really just going to talk about the technique and then maybe a couple different things you can apply it to. And I really want to see what everybody can come up with this idea. So here I am in the Grayscale Gorilla Instagram and a bunch of the different things that went up. And there's this cluster of 4 that I put together, and they're all using this technique. So we've got this one. And so what is the technique? Well, it's pretty much we can get sweeps and lines and traced lines, but they're not intersecting each other. And not only are they not intersecting each other, we can do things like get these really awesome coiling things happening. So like all these lines are passing through and wiggling around, but you see that they're not intersecting. Now, it's possible that they do. It's not a perfect system, but it does a really good job of avoiding. That's why I don't call it like collision detection or anything. It's collision avoidance. It avoids collisions the best it can. So all these images were made with this technique. We can actually, so you see it's all nice and tangled up, and then it gets pulled up here, and it kind of starts wrapping around this model really nicely. So we can do things like that. Here I have kind of matching a model, or I have a model getting swept around it, and all of these pencils are getting all kind of tangled up, but they're not colliding. And then even this one was made with it, where there was actually one particle, and I made that one particle spiral around and around and around, and actually eventually traced over this entire object to create this model. So we want to be able to apply this to those types of scenarios and lots of others that I can't even think of. So really, we're just going to talk about the techniques and what we might be able, things you guys might be able to make with it. So why don't we jump on in? So here we are in Cinema 4D R17, and we are using X-particles 3.5. I think this would work with 3, but hopefully everybody's all up to date with 3.5. So let's just start right out. I am going to create, and the same basic structure applies to all these techniques. And there's just a couple little settings you tweak to make it apply to different things. So let's get that basic structure, which is logical, but yeah, there's a couple steps to it. So what do we need right away? Well, first, right away, of course, we need an emitter. So I'm going to create an emitter, and I'm going to tell it to emit upward on Y. So if I were to hit play, you see we get a bunch of nice particles. I'm going to make it a little more visible, so I'm going to go to visibility, change these from dots to filled circles, and that should make those stand out a little more. Now, I don't want a constant stream of particles, so I'm going to go to the emission tab, and I'm going to change it from rate to a shot of particles. And how many do I want? Well, I want 5 particles. So what this should do is boom, emit 5 particles, and it's done. We've emitted 5 particles. So we want these particles to avoid each other, and we want them to avoid where they've been. So how do we do that? Well, we need a way of them knowing where they've been. So the way that I figured out to do this is to have a trail of particles constantly kind of following them. So why don't we set that up? So right away, we've got this emitter selected. And I'm going to, actually, what do? We ask a question. I'm going to go into questions. I'm going to ask a question. And what is the question? Well, I want a constant trail of particles. So anytime when the age is greater than 0, so pretty much always, I want it to do something. What is that something? I'm going to add an action. And I want a direct control. And I want direct control over what? I want direct control over control of spawning. So we're going to control spawning. Now, what does we click on the control spawning action, and it wants an emitter. So we need another emitter. So I'm going to go ahead and go into X particles. I'm going to go into XP emitter and make a new emitter. And I'm going to call this XP emitter trail just to differentiate this one and this one. So I'm going to grab the spawning action. I'm going to drop the XP trail in there, and let's go ahead and hit play and see what happens. Oh, well, you see, we get a big explosion of particles right at the beginning and nothing else happens. Well, it's happening for a couple reasons. First of all, if we go into our particle age, you see that right now, actually, we go into the emitter. If we go into the emitter under the question, you see that we're asking a question, but we're putting this in under the tab of test and pass once. We actually want it to go all the time. So we're going to move this question into the test all frames category and delete it from the normal test once. So right at play, you see we're going to get a bunch of explosions all the way. So obviously way too many particles. So I'm going to fix that really easily by going into our controlling spawning action, and I'm going to set it to Actually, right here, it's numbers of particles to spawn. We're going to drop that down to 1. So it's going to spawn 1 particle per refresh. And actually, that's all we do there. So now we're going to get 1 particle per. But you see they're still going to be flying off. So we have to go into that XP emitter trail, go to emission, and drag our speed down to 0. So that's great. So now I let it go. You see we get a nice little trail. I want to make that nice and visible for you. So why don't we set this to... I'll set it to circles, and we'll set it to a nice bright blue. So now you can see we get this nice trail of circles. So that's working great. We got a trail, and we know where these particles have been. But that's not quite ready, because let's get some random motion going in here. Easiest way to do that is to go into Xparticles, Modifiers, Motion, and grab a turbulence. So with our turbulence, as soon as I hit play, you can see everything starts wiggling around. But unfortunately, everything starts wiggling around. These trails are fading off and kind of, just blowing away in the wind. We need them to stay where they're supposed to be. We want we want these lead particles to kind of move around, but we don't want the trails to. So we need to freeze them. So I'm going to go to our XP emitter trail, and we're going to add a question. I'm going to add a question that's going to be the same as before. I want it to, if the age is greater than 0, so the instant it's born, I want it to add action. What is it going to be? It's going to be another direct action, and that direct action is freeze the particles. That's straightforward. We get the freeze particles action now. It's freezing the movement and the spin and the scale. We actually need the movement, but that's fine. Now I can go ahead and hit play, and now you can see that our lead particles are wiggling around, but the base, these guys aren't moving anywhere. That's working great. So let's see. We're definitely going to need more frames. I'm going to drag that way up to like 500. So now I got lots of different frames, and we see that these are flying around doing their thing. But they're not interacting in any way right now. We just have a trail of particles. And also, why don't we save this? Because, we're going to be doing a lot here. So didn't I just make a folder? I did, but it's on the desktop. Tutorials, Xparticle avoidance. Avoidance. 1. All right, so what's next? Well, next we actually want these guys to start interacting in some way. So we need these to avoid each other. So we're going to use the amazing Xparticles Dynamics Objects XP Constraints. This is a great dynamics object for Xparticles. It does so many different things, but we're going to focus in, well, it does connections, you can do collisions, you can do viscosity and friction and surface tension, lots of cool things. But we are only interested in one of them, and that one is going to be particle forces. So let's see, by default, we have the forces limit. What the forces limit does is, I think, the documentation isn't super clear in this, but it's how many particles I think each particle can interact with. So with a limit of 16, I think that this particle is interacting with the 16 closest particles to it, I think. I don't know that for sure. That actually might be a little higher than what we need it to be. I can drop that down to 5 for right now, I think. We might end up changing that later, and it has some slightly different behavioral changes, but let's just do that for now. Also, by the way, almost kind of stylistically, the way we want these moving around, almost all the control that we're going to need is going to be right here inside of forces. So what behavior are we looking for from them right now? Well, right now they're a little bit attracted, a little bit repulsed by each other. So I'm going to say we don't need any attraction right now. We will later, but not right now. And I want them to be repulsed by each other, a whole bunch. So a 10 centimeter radius, lots of repulsion. So and right away that's affecting all particles in the scene just because of this setup that we have. It's all kind of open. Let's just go ahead and hit play and see what we get. Oh, well, look at that. Definitely different. Well, a couple things to note right now. Right away, you see it's a little different. You see that they almost seem to be moving faster. And you can see these guys are all kind of clustered up a little bit. A little bit of weird separation there. It actually took me a really long time to figure this out. But let's kind of think about what we've got going on here. In fact, why don't we simplify? We're going to have this emit one little particle. So it's just emitting one particle. So what's happening is the particle is flying at a certain speed, and then it's creating a particle as part of its trail, kind of like, okay, this is how far I am. But now the constraints are telling these particles that they are avoiding each other a whole bunch, and they're avoiding each other by a radius of 10. And if they're closer than that radius of 10, they kind of get pushed off to the side a little bit. For the most part, that doesn't matter too much. Like a little bit of variation in there works pretty well. And there's certain combinations can make there be less or more of those. But there's a little bit more to deal with here. First of all, a limitation of the setup is because these particles are all forcing each other apart very strongly, which I think we do want it to be strongly. We could set that to be a lot softer, and you'll see that they're not forcing each other away nearly as much, but that means they won't be avoiding each other as much. So there's a big push and pull on that. But if we have this cranked up, there's a bunch of different variables. And for one, actually, how can I show this most straightforward? If I turn off constraints, I'm going to go to my emitter, and I'm going to tell it to emit, but to emit very slowly. It's only going to be going a speed of 25. You see it's moving nice and slowly. I'm not going to change that speed, but now we're just going to go and turn on these constraints, and let's see what happens. Now look at that. The particles go zoom, and it's flying away really fast. Well, that makes sense because they're being told to avoid each other. They're being repulsed by each other all they can. So if it's closer than 10 centimeters, then it's being forced away pretty fast, and it can actually accelerate it even beyond where, so that becomes a minimum. This radius becomes a minimum distance and a minimum speed at which our particle is traveling. It has to travel a minimum of 10 centimeters per frame. So if we were to start setting this to smaller increments, you see that it's going to start traveling slower. So there's a push and pull on that. Just something we need to keep in mind. So that's working pretty well. I think that the radius, let's leave the radius at 10 just because having this little bit of randomness in there, I just want to show you that it does have a little bit of effect, but not too much of an effect. And let's leave it in there as a variable. Okay, so that's working great. Why don't we go ahead and start tracing this particle? So I'm going to go into X particles. I'm going to click on, I've got my XP emitter here, and I'm going to click on XP trail. And now we should get a nice little trail following behind there. And it's pretty much ignoring these little guys. It's just going where the green one went. So let's get a few more. I guess actually if we have enough frames, we can just do the one particle. So we need to see if this is actually avoiding itself. So why don't we go ahead, and the easiest way to do that is going to be to create my favorite, X particles, modifiers, motion. Actually, no, we already put the turbulence. We're going to add an attractor, my other favorite. Okay, so I'm going to create this tractor. I'm going to move it up here, and it should attract all the particles, but the other ones are frozen. So just the main one. But we need to attract a lot. So I'm going to try 300. And let's see, it's going to fly up and go past it, and now you can see it's swirling around it. So that's actually working pretty well. So let's check out what it is doing. Well, interesting. Let's hide the trail particles. So I'm just going to make them invisible. And look at that. It looks like this line is avoiding itself. Let's hit play a little more and look at this guy zipping around. And that line doesn't want to intersect itself. So why don't we make this a little more clear by creating a sweep? And I like creating end sides. So I'm going to grab this end side and put in the sweep. I'm going to grab our XP trail and put it in the sweep. And obviously it's way too big, so I'm going to grab the end side, hit the letter T, scale it way down, and now we're going to get a nice line. So right now, yeah, it's a fairly thin radius. Now, like I said, this is all about avoidance, so it's not perfect, and we might even be, okay, see right there? Like you see, like it looks like in this one spot we are getting a little bit of intersection. But in all these other ones, it's definitely avoiding these to various degrees. And you can see as I kind of frame forward, like it's traveling in and traveling around. And there's a lot of different things we're going to be able to tweak here to kind of dial that in some more. Why don't we actually see if we can do that? I'm going to go into my constraints, and we got a couple different things. First of all, we got our radius. This is where it starts pushing away. And right now it's a cubic fall off, and it's hard to kind of picture what that is, but something that's cool is we can change it from cubic to custom. So you can see we kind of get this nice little soft transition. So presumably, as it gets closer and closer and closer, all the way to being on top of it, the power is getting stronger. It's saying like avoid it even more. So it's far away. It doesn't have that much avoidance, but when it gets close, it has a lot. So something that will help a lot here is actually I'm going to click in the box, hit Command or Control A. It'll select all the points. I can right click, change my point type to soft, which will give us handles. And what I'm going to do is tell this top handle to be cranked way the heck over. And I'm actually going to leave this bottom one kind of where it is. It's just a little straightforward here so we get that ramp off. So what's happening is there is a little bit of a fall off here, but what it's saying is avoid this collision very strongly. As soon as you get within the range of 10, pretty much avoid it, pretty much full strength. There's a little fall off, but it's a lot stronger. So let's see what that gives us. I'm going to hit play. This comes up, flying around, and now it's twisting around, zoom in all over the place. You'll see that the line is actually twisting around a little bit. I'll do a shortcut NB will show us the polygons. You can see it's actually twisting around. That's just something the sweep does depending on the angle of your points. We can hide that a little bit by increasing the number of our sides, hitting NA and just going back to these polys. So now as this is zipping around, with any luck, it's doing a slightly better job of avoiding the collision. You see these things are traveling through each other really nice. We got one collision there. It looks like there's even another one here. Parts of this could be like, and once again, this is avoidance. Like it's saying push away, but this attractor is saying no, pull in close. So they're fighting each other. So this attractor being so dang strong could be one of the variables for why those are starting to intersect each other a little bit. If it's weaker, then it's a lot smoother, and you can see it starts twisting around. Hopefully, getting less intersecting going on. But I'm going to leave that at the higher number for a second, and now, actually, something that's cool is why don't we go ahead and add a few more particles in. Go back to our original emitter on the bottom, and let's just have it emit the 5 of them again. And let's hit play, and boom, 5 particles all flying. And here's something that's kind of cool. They're all being attracted to the center, but once they get to this point right here, they don't get any closer. And it's because they're starting to repulse each other. So now we can play, and they're all going to twist around and do their best at avoiding colliding. There will still be some, but it's doing a pretty dang good job of avoiding them running into each other. So let's talk about a couple other things. First of all, when they're doing these really tight-angled kind of avoidance situations here, you can start getting these really hard-edged kind of kinks in it, where really sharply, whereas I don't see any super blatant ones. I'd like to find one. I mean, this one's pretty sharp, but it's not like over the course of a single frame. Here's a reasonable example of one, but like they can get way worse than that. Okay, here's one. Like, like it's making these really sharp turns. So what are some ways of fixing that? Well, this actually, I think it used to be a bug in Xparticles, but it is now fixed. I'm going to change my display mode so you can see all the different segments. So right now it's sampling the particle as it's traveling around every single frame. But if we start increasing that, let's say to 3, it's only tracing the particle once every 3 frames. You'll see there's actually a larger section of distance in between each one. So it's a softer sampling. And what that translates to is we can now go into and maybe 3 is too high, but now I can go into our XP trail, and we have our spline type, and right now it's linear. It's saying, I recorded here, and I recorded here, and I recorded here, and it's just connecting them. But we can change this type to something else. And let's say B-spline is actually the smoothest. And we can turn on our intermediate points to something like natural, uniform, or adaptive, whichever one you want. I'm going to do natural. Natural keeps an even number of subdivisions going. And now you can see that what used to be that really sharp turn, it's actually the same thing as right here, but it's traced less often. Excuse me. It's traced less often, and then we're telling to smooth it. So we get this nice smooth arc. Now keep in mind that means that it's kind of rounding it a little bit, which means there's even a slightly higher chance of these potentially intersecting each other a little bit. But it does result in these nice smooth curves. Now I could go and decrease the sample radius down to 2, which means it's smooth, but not as smooth as we were just doing, and let it trace around a little bit. You can see we get this really sharp, we have this sharp angle. It's sharper than it just was, but it's a lot smoother than it had originally been. And we could even potentially be doing every single frame and let it trace, and you see we get a lot of polys now. And you see we get these kinks, and they are smoothed out, but you see they start pinching in a little bit. So I tend to like to trace like every other frame. It just smooths things out just that little bit. That is nice, and kind of gives you a good medium, a nice little in between. So that's working quite well. So we've actually got some things right away that we can start tinkering and playing around with here. Well, first of all, we're getting that really harsh like collision in between here. And really, it's just a lot of push and pull here, where we can go into, I guess, a big one. The big control, of course, is always going to be this constraint. So we could say, like, maybe this is a really strong fall off, and I do want it higher, but not maybe that high. So you get a little more time for them to fade into each other. If I hit play, it is going to behave a little bit differently. And it is all moving quite quickly. In fact, we didn't do one of the things I wanted to do. Which is add in maybe a little bit of speed control. So I'm going to go ahead and hide the line, and let's just take a look at our guys as they're zipping around. Now, as these are being forced forward because of our large repulsion radius, They might actually start accelerating faster than they have to. Because it got pushed really far forward and it's maintaining a certain speed. This doesn't make a big difference, but a little bit of one. Something we can do is add in a modifier, I think motion, speed. And so we can add an X particle speed controller, and I'm going to tell it to set the speed to an absolute, and I can set that down to a low number, like 20. And now what it's doing is constantly trying to slow all the particles down to the maximum amount that it can. And actually, you see it did slow it down quite a bit. When this isn't on, these guys are zipping all over the place because they're being forced to accelerate. But now that they've slowed down a little, they might be avoiding each other a little bit better. So why don't we take a look? I'm going to turn these back on again. Let's hide the trail again. Oh, hide the dots. And let's let these guys travel at what is hopefully a little bit slower and more consistent speed. Let's let these play. Am I tracing every other frame? I hope so. Yes. Okay. So let's let them play. And they're a little bit slower. They're zipping around. But let's see what we get. Like, they're making... Okay, look how much better this is right away. I'm so glad we added that speed in. I thought it was looking a little worse than it should have been. And now look at these incredible feats of avoidance that we're getting. Look at this line comes in, and it almost collides with that one. It goes, no! And it shifts over this way. And then it sees this one. It's like, no! And it shifts again and travels over here. And then this one starts... getting, I don't know, maybe that one just wanted to turn, or the attractor pulls it down and it yanks it down again. So we're getting some very nice, like none of these seem to be touching each other at all. These are working great. So I can hit play and let this keep going and going and going. Let's pause it, give ourselves even more frames, a lot more frames. I'm going to hit save. And let's let these trace for a little while longer. So once again, the attractor is starting to pull these in, and they're all being avoided. And there's always that existing trail of particles that these are trying to continually avoid. Now, and look at these great twists we're getting. So what's happening is, like, this little guy is being... I guess it's the other direction, but it's like forced in here, and I guess it comes in from this direction. It's traveling around. It sees this pipe. It kind of starts avoiding it, and it gets in this cluster, and all of these different ones are pushing it away. So it shoots down here, and it's twisting around. It gets down here, and it sees this one, and then twists over here to avoid it, and it starts getting in. And so here's where an important note is once they start getting into these tight clusters, they can't make quite sharp enough turns. So the tighter they are, they're doing the best they can to avoid, but they'll still start getting a little bit of intersection, especially when it gets all clustered. But on these outer areas, they should be very cleanly avoiding. Like, there should never be any question of them colliding here. You see over here, it very cleanly gets near and it pulls away. Now, these are, of course, avoiding at a radius of constraints 10. Well, it's not exactly 10 because it gets stronger. So about 5. Like right here, it's like, okay, pretty strongly avoiding. Which tells me that, which is actually about the radius here. If you keep in mind the radius goes both directions. But we could probably even increase this a little bit where these start getting fatter. This is just the sweep. But you'll see that they're still not really intersecting. This is the distance where I'm probably, as I drag this up, like as we get to these bigger amounts, they're still avoiding each other. We get these really kind of fat areas where they're not, a fatter pipe, and they're really clustered in there, but they're avoiding each other pretty dang well. Like, look, let's see what this one does. See, this one's getting close to the cluster. Let's hit a frame forward. Totally turn to do its best to avoid it. So all that is working great, and it's just important to keep in mind how they're going to get tighter and tighter and cluster up more and more in the middle as they get into those tight squeezes. Well, I mean, I guess here's the point. Is like you can fly in. It's like, oh, okay, cool. This is a nice big opening, and then suddenly it kind of dead ends inside of it. And it's like, where do I go? And it's going to take the best path it can. And it's actually, it does have almost an intelligence to it where it's like, this way is slightly better than all the others, so that's the one I'm going to go. And that translates to it was the biggest hole. So, okay, awesome. That is working great. And that's just with them attracting. Now, something that's pretty fun with them attracting, and I guess it's good to leave all these on, but I want it to be running as fast as possible. So I'm going to go to our spline here, and I'm going to turn off our intermediates. So these should become quite linear. But you see that they're flying around. Actually, ooh, did I do that wrong? I did. I want to leave that on B-spline and turn off in between points. So now we're running nice and fast. So these are all being pulled at the attractor, but what's cool is it's all live. So I can actually grab this attractor and pull it over here, and they all want to get over there. And now they're going to be trying to cluster around that point. I can pull it way up here, and they're all going to try and aim up there. You see, this guy didn't come right away because he was blocked by these pipes until he found an opening and then came over. So we can kind of artistically pull these around and whatever, draw different things. Like as soon as they get to a spot, they'll all kind of break out in their different directions and then go back there, and then we can have them come down here. A lot of control to be able to artistically direct these. And it goes further too, because like this attractor, we could put a fall off, so we could put one attractor here, they could get pulled over there, but some of them escape and get over to this one. We could have wind, we could have so many different things going on. And so along those lines, why don't we, instead of using a tractor, let's try something else. I'm going to turn it off because we'll probably use it again. And I'm going to go ahead and hit save. I'm immediately going to save it as a new file because we're going to kind of go into a different vibe now. So what's going to happen now is they're at a certain speed and they're traveling and they're all just kind of avoiding each other, and there's a little bit of turbulence. Why don't we create an object? Let's start with a sphere. It's nice and straightforward. I'm going to create the sphere. I'm going to put it right here. Maybe even make it a little bigger. Actually, I'm going to move it down. Nice big old sphere. Right click on the sphere. X particle tags. XP collider. I love this tag. It's so great. So right now it's got bounce, which is fine. If we hit play, these are going to go up and then hit the surface and bounce off. So working great. No problem with that. We don't actually want any bounce. What we do want is attraction. Now, this is a weird quirk I found. I don't know if it's a bug or just something I don't understand, but I'm going to crank up our attraction to something reasonable like 25, and let's go ahead and hit play and see what happens. Well, it's going to hit the surface and just kind of bounce off and fly away. It's like, well, if it's within the radius of 10, it should be it should be have an attraction. It doesn't work, but for some reason, it needs a little bit of repulsion. And now, I'm going to hit play. Boom, it's going to hit the surface, and look at that. Every one that hit the surface is now stuck on the surface. Actually, I'm curious. If I put that back down to 0 and hit play, what happens? Okay, they do still bounce off. So for some reason, they want a little bit of repulsion. I don't know why. But now what's happening is they are being attracted to the surface as long as they've hit the surface. And it's a certain amount of attraction, which is 25, not super strong, and it's only within a very tight radius. So right away, something interesting happened here. They all kind of met here at the top, and they all met right here at the same time. In fact, these two got there at the same time, and this one hit that one, and it whoop, and went this way, and it hit that one, is like whoop, and then they tried to avoid it, and they avoided it by shooting straight up, and it was more powerful to push away from them and go straight up than the attraction of the object itself. So we got two big variables to deal with there. How strongly attracted it is and how big the radius of the attraction is. So why don't we try increasing the radius of the attraction to 25 and just hit play again. Let's see what happens at the top. Nothing should change too horribly differently. Actually, I guess a bunch of things did change, but look at that right away. This one hit one corner, bounced off another one, and it's still maintaining it. Now right away, you can see where things start getting interesting. This one was traveling up, and it got pinched in between two other ones, and it got pinched to a point where it's like, no, they're pushing me away too much. I still want to be near the sphere, though. So it popped up and then traveled over this one and then got sucked back down to the surface. And now it's continuing to travel along the surface. And so you see the same thing just happened over here. It jumped over itself, and then actually it jumped up, went down, and then it traveled under itself. And now it's traveling over here, but it can't fit through there anymore, so it's traveling over itself. We got a little bit of an intersection there. It just happens sometimes. But yeah, these guys are all now traveling around, and we're getting this amazing vine growth. Like we now have like very awesome looking vine growth. Now we can actually go further, and there's a lot of additional things we can do. Of course, we can always go back to our constraints and do things like increase our radius to, let's say, 15. So now they're avoiding each other at a greater distance. Keep in mind that as we increase the radius, it also increases the speed. Those are just kind of two variables on itself. Now, a couple of them are escaping because our radius is bigger and stronger. We can definitely fix that. I'm actually going to go back to the size. It's fine. And what I'm going to do is shrink the radius of these, which is effectively doing the same thing. Now they're tinier, but they're going to avoid each other better. It should just visually look better. It's actually the same simulation as before. These always tend to be identical. But yeah, these are all working great. Now, what is some of the next things I want to talk about? Well, first of all, we've got more things we can do on the surface. We got the radius. I could actually increase that radius to like 100, and now it's constantly attracting it from all over the place. It's going to be really hard for them to escape once they've kind of been sucked into the gravity of this sphere. So let's just let it play, and I think we'll see that none of them fly away. Like they're all here, they're zigzagging, they're jumping over their own pipes and doing all this great avoidance, but none of them have escaped the surface. They're all stuck on it. So yeah, wonderful on that regard. But what else do we have? Well, we also have repulsion. And repulsion's great as well. So here's what I'm going to do. I'm going to tell it to have a repulsion of 100%, okay? But it's got a tiny little radius. But what we now are saying is, like, it's attracted from a big distance, from like 100 from the surface, which could be like up to this far away. But the repulsion is relatively small. I'm going to crank that up to a number that we can actually see. Let's even say 50, a pretty big number. And you're going to see that all of our vines are now, they think that the surface is 50 further away. Now, that's only because we have the repulsion cranked up to 100. It's a very strong repulsion. But you can see that they're actually kind of traveling through the air a little bit. But what's kind of good about that is we can, like right now, all these vines are traveling across the surface, but they're traveling along the surface and kind of intersecting it. So what this kind of can translate to is the surface could be like 10. I'm going to rewind and let it go again. And now they're on the surface, but you see they're a little bit away from the surface. And maybe 10 is too high, so let's go drop it down to maybe 6. And play again. And now you can see it's very closely traveling along the surface. You can just set the radius to whatever you want, and it's going to kind of avoid it by that little extra bit, that little extra distance. Other things we can possibly tweak on top of this is right now we have a fairly strong attraction, heavy repulsion. I can actually set that attraction to a lot less because we have a fairly large radius. And now what might happen, I don't know this for sure, we got to find the magic number. Actually, 10 is still pretty high. We might have to go a very low number to actually see this start happening. I'm going to drop the attraction down to 1. Let's exaggerate this a bit. And what I think we'll see, and I'll hit play and rewind, as all these are traveling around, but they go to avoid each other, and it actually takes a second for the gravity, the attraction of this object to pull it back to the surface. So it hit here, shot up in the air, and instead of being attracted back very quickly from a strong attraction, it very weakly got pulled back and then got back to the surface. So this could actually end up with some slightly more interesting, and you can kind of see how they're bouncing and wobbling on the surface a little more. There's a little more variation on it. And I feel like you get slightly better twisting vines going when you have a weaker attraction. So these guys are all, kind of pulling and pushing away. This one might have escaped. Now keep in mind we can actually set this radius up to something like 200 or 2,000 or something huge. Where they really can't escape. They're always going to be pulled back in. So yeah, these are pulling around and doing their thing, and they should do a great job of wrapping around and doing some really nice vine-like things. Now let's see, what are some other things to do? Well, there's so many things to do. A lot of at this point forward, you've got it. We've already got the avoidance. It's just playing around. But I'm going to take this sphere, copy and paste it, and why don't I take this one and move it right there. So now we've got another sphere that has a lot of attraction as well, and let's see what this does. Well, these two can kind of fight each other. Actually, that's kind of interesting. You'll see that it's almost created a gravity vortex in between the two, and they're kind of fighting each other a little bit, and they're both attracting them all the way, so they're kind of stuck there. But what can we do? Maybe we can grab both of them and say, you know what, your radius is only 200. Let's see if this helps. I might need to go even lower. Well, that's interesting. I was hoping that we could kind of get these guys to start traveling from one to the other, and I think we can with the correct radius, but I don't want to dead end with that. I thought we could kind of easily get one attracted to the other shape. And right now, yeah, I guess the gravity between them is just kind of pulling. We'd need them to... Yeah, we need to be a little fancier to do that, so let's not worry about it. But anyway, we've got this shape, but it doesn't have to be the shape. Why don't we grab... Ooh, a tube could be interesting. Let's grab a tube, and I'm going to put the inner radius a little bigger, and let's steal our tag and put it on this torus, or on this tube shape, and let's see what happens. Well, there we go. Look at that. They are being attracted. I did set it to a smaller radius. We might want to set this to be a little bigger. But they can actually travel on the inside and outside. It's as straightforward as that. Like right away, they are being pulled onto the surfaces and attracting around these corners and nice and soft and pulling around. And it's going to grow around this object. It can be any model, any shape. It's going to be trying to grow around it. You can totally capture this object via a bunch of vines. And let's keep in mind that right now we're just emitting 5 particles, but let's go into our base emitter and emit 15. So we're going to get an explosion of 15 of these lines. And all of them are following these same behaviors, and they're all avoiding each other, and now they're being all attracted to the surface, and they're all going to be twisting around. So kind of with 5, we have 3 times as many particles, so 3 times faster it should kind of wrap around this object. So excellent, that's working great. So, okay, that's with this tube. I'm going to turn it off. Let's save that object and let's go save another file. Let's talk about another attribute of avoidance. Let's turn the attractor back on again. So these are all going to be attracted to this point. And I'm going to drop the number of our emissions back down to 5. In fact, why don't we drop it down to 3? And now, let's see, is the attractor on? Yeah, the attractor's on. It's over here. So let's move it up in the air. Actually, I'm going to hit Shift-C, PSR, which is going to be reset PSR, and I can zero it out and then drag it up. So now I can hit play, and these three guys will get pulled up in the air, and they're just avoiding each other, which is great. They're avoiding each other, and they're attracted to this attraction point. Now, why don't we try playing with some attraction? Right now, we've only been playing with repulsion. So let's try adding a little bit of attraction in here and see what happens. And let's start small. I'm going to start with an attraction of 1%. This might actually not be as sexy at a low number. I'm going to turn off the attractor, and now we just got 1% attraction. Let's see what this does. Not much. The turbulence is too strong for it. I'm going to turn off the turbulence. Let's see if that does anything. Okay, too weak. Let's jump it up to 10%. 10% attraction at a distance of 20. Oh, look at that. We've got a very different behavior going on. So what is happening now? Well, what's happening now is they are being attracted. Well, actually, they're not even being attracted to each other. They're being attracted to their own trail. So right now they had been avoiding their trail, but now they're being attracted to their trail. Now, it's important that the attraction is lower percentage-wise than the repulsion. But I'm going to actually go ahead and drop this down to 1 particle and let's see what happens. So it might just, okay, 1 particle, and you'll see it's starting to twist around itself. It is attracted to its own trail, and you see it's just twisting around and making its own little cluster. So this is kind of interesting. This is showing that these kind of want to be clustered up together. So we can actually start making this a little bit more interesting. If I go and, let's throw 5 of them in there. So they'll all be doing the same thing. They're all kind of twisting around each other. Now, look at that. Look at how these guys just kind of twisted out and went on their own little trail for a second before pulling back. Like that is an interesting behavior. And look at those. They spiraled around each other, and now they're kind of clustered by themselves over there. Now, let's keep in mind that our constraints are being told to only pay attention to the 5 closest particles. So if we set this to a higher number, let's do 15, I think they're going to be a lot more likely to kind of stay in the middle and really tightly wrap around each other. You see how tight these clusters are? And as we drop them down to lower numbers, like 5, you'll see that they're not as tightly wound together, and they can kind of escape and go traveling around a little bit. Let's drop it down to 3. There's probably a minimum number. But, okay, when I went down to 3, it's just too small, and they're all kind of just... And you see that there is no turbulence, but they're still kind of doing these weird little wiggle, like travels, weird little traveling around. And it's because they are attracted to their own tails, which is weird. There's an attraction to their own tails. Let's jump this back up to, let's try 10, a fairly high number. And actually, right away, this is kind of interesting. You'll see that each one is immediately kind of attracted to itself, and it's kind of just winding its way around its own geometry. But let's go ahead and rewind. And in addition to this, let's turn on our attractor. So now they're attracted to their own tails, and each other, but they are also attracted to this attraction point here. So if I hit play, they are all clustering up with each other and twisting around a little bit, and that one's gotten lost by its own tail. But they're getting pulled up towards the attractor. And this one finally made it, and look, it's traveling up the tail of that, and now they're at this attraction point. And I can pull it over here, and they are very attracted to each other, but eventually they start getting pulled in this direction. And you see there's still one over here that's fighting a little bit. Oh, actually, he might have escaped. It's hard to tell. And now they've all traveled over here, and I can pull this up. And now slowly this attraction is stronger than their attraction to each other, so they slowly get pulled up here. Now, if we started really pulling up their individual attractions, if we started increasing this number to something significantly higher, the attraction might not be able to pull them very well away from this cluster because they're very attracted to this cluster. So if we made that even more so, let's go ahead and rewind. And I'm going to set the attraction up to, let's try 25. With the attractions being higher, it becomes less likely that they start heading in the proper direction. Now, they're always kind of want to go in that direction, But this can kind of override it. And I feel like eventually they'd always make it there, but the stronger their personal attraction, the longer it's going to take for them to make that jump. You see right now, like before, they kind of immediately shot off. Now it took a little while. And look at this. They're a lot more twisty now. They're attracted to each other a lot. And you got this guy here, and he doesn't want to move away. Look, he's slowly moving away, but he's still very attracted to himself. And now, look, they haven't gone all the way, but they're all starting to fight each other. And they are all generally moving in this direction, but they like hanging out with themselves a lot as well. So there's a lot of push and pull there. There's no kind of hard and fast rule of how to set that up. But you'll see that the style that we're getting here, especially if we go back into that XP trail and give us some intermediate points, these are going to smooth out really nicely. You see the coils. These are the coils I was getting in these renders. Here's the coils. And so the way I made this render, why don't we just go ahead and do that real quick because it's so straightforward, is if we go back to our original emitter, I'm going to set the original emitter to not be a rectangle but be a sphere. And I'm going to tell it to... I'm going to say emit from the surface only. I'm going to set it to a big old radius, and that should be fine. So what's going to happen is now I'm emitting 5. How many do we have? 5 particles. So 5 particles are going to emit from the surface, and they're all going to be attracted to this attractor. And I should probably set that to 0. So Shift-C, PSR. And now all these are being attracted to the center point, but they're also attracted to their own tails. So you see that this guy is moving towards the center, but in a very twisty fashion. And depending on how high I crank that, they can really start clustering up on themselves. So you see that right now it's very twisty. But if I go back to my constraint and I set this to a lot lower number, let's say 10, you'll see that it is still twisting around. Let's give it a second. Right now there's a... 10 is still a relatively high number. This one just seems to like this pile. Let's try it even lower. Drop it down to 5. By dropping it down to 5, I don't want to make any judgments here. It's still really twisting around itself, and all of these are going to have slightly different behaviors. It's still very attracted there. I'm kind of surprised it isn't pulling. Now you will notice that overall it is still pulling in the direction of the center, but it is still very attracted to its own cluster. Now let's also keep in mind that there's kind of the forces limit is a multiplier. If I set this down to 5, it should probably start immediately heading towards the center, okay? So now maybe we can mess with that number a little. Let's set it to 25. 25 and 5 for the attraction. So now it's not the kind of overall, it's just the one's very nearby. So now if we kind of find a nice in-between number, so 15 attraction and a force limit of 5, it's still twisting around itself quite a bit. Let's drop that down to 4. And I do want some twisting, but I do want it to also pull towards the center. So you see how just tweaking those numbers around has made all the behaviors change a little bit. And you can even see all of them are kind of stylistically doing similar things. Like they're all very nicely spiraled. Here they were very kind of snaky, clustered, and then they got kind of wiggly, and then they did their straight. And we kind of see that pattern repeating in all of them, even though they're kind of all doing it their own way. And now as they all get attracted to the center, you see that they're all going to avoid each other and start doing this big snaky pile, which exactly creates this image. Super cool. Yeah, that's all super fun. Now that also translates to, I'm going to set this back to, I guess we'll hit save on that. We'll add avoidance 4. What's next is, what is next? Let's go ahead and go to original emitter. Let's set it back to a regular rectangle emission. So it's just going to go pew, and now they're all wanting to be clustered up with each other. But let's go ahead and put some geometry back in here. I'm going to create this one, and let's put the shape on that. We now have the collider moved onto this shape. And now we can hit play, and they should all collide with that, and they're all going to be kind of trying to travel around that surface, but they're also traveling around their own line, so they might get pulled down into their own twistiness down here. And that's all kind of a fight between the attraction of this and the attraction of themselves. So if I pull this attraction up to 10, they should be a lot more likely to start traveling around the surface. So yeah, they're starting to travel along that surface a lot better. But what's cool is look at this ropiness we're getting. Look at how they're tending to be a little bit more clustered. Look how these guys are neighbors now. They're traveling together. And that's because they are attracted to themselves and their own tails. And you'll see that this new one traveled along that trail as well. And so we just get this really nice kind of organic vine-like behavior where they're all kind of clustering around each other. And this is really just kind of about combining these behaviors. Like, how attracted are they to their own tails? How attracted are they to each other? How attracted are they to this attractor? How much is the wind and the turbulence having an effect on it? Because they do have a big of an effect. And, you know, right now in the forces, like, it is attracted a reasonable amount here to this attraction, which is great. But we can make it a lot lower, and then they'd be more likely to fly off of the surface. Right now, and as these cluster up, you know, clearly they're more attracted to this big pile. But the more that the forces, well, I guess the forces limit is already down to 4, which is a fairly small number. They're all, you know, yeah, I guess there's not much more to say there. Like, they're just going to follow along this shape very well, very tightly. This is, and this is on the outside of the shape. We could always go and change this to collide with the inside of the shape, and I think that should mean this is going to fly, and I guess the attraction is always on the outside. We have to invert the normal to make that happen. So let's not even worry about that. But you can have these trapped on the inside of an object. Oh man, let's make a letter. Why not? I'm gonna make a motext, and actually let's go ahead and see if we can trap it inside, because I don't super specifically remember. Let's make a nice big ampersand, and let's change a font. It's going to take a second for my hard drive to spin up. Oh, I don't care which one. I'm just going to grab maybe impact. I just want a nice big beefy letter. Nice and chunky there. Let's make it a little bit deeper. I'm going to move it up in the air and then over a little bit. Actually, that's not true. Why don't we move it down like that? And now it's trapped inside. It should be trapped inside. So I'm going to go to my motext, and I'm going to right-click on it and put a display tag and set that display tag to be lines. And now it should make it kind of invisible. We should just kind of see that. And I'm going to steal the collider tag and put it onto my motext. I don't know. Well, and also let's make the poly count a little more even. Right now it's set to adaptive. I'm going to jump that to 25. And you'll see that we get, you know, slightly better subdivisions on our chunks. There could be things I'm missing, but let's see. Okay, well, it clearly escaped right away. That's not helping. So right now it's set to be on the inside of the normals. And I wonder if the repulsion, I'm going to turn off the repulsion because I don't want it to be repulsed. I just want to bounce off those edges. Let's see, rewind all the way and see if that's kind of working. It's not. Let me think. I did get this working, but there might be another trick or two. I'm going to grab connect object, throw the motext in there. And let's throw both those tags on, and let's hit play and see if that helps. Oh, yeah, it totally seems to be helping. So now it had to be made editable, pretty much. Well, I mean, it had to be welded or made editable, but now you see it's actually trapped in there. And I wonder if we can put the repulsion back in again. Does that force that outside, or is it keeping it in? Yes, the repulsion is forcing it outside the object, so we don't want any repulsion. In fact, I don't even think we need any traction either. We just need it to be inside the surface. And you see these are all getting clustered up and moving around. But if we tell the constraints what we don't want them to be attracted, I'm going to turn off the attraction, but they're still trapped. So they're avoiding each other, but they're still trapped inside of this object. And so now what we're doing is we're filling the volume of this letter with weird worm snaky things. Like, these are all trapped inside, and they're going to wiggle around and fill this volume. Right now, I guess it's pretty fat, so we can try and make it skinnier. Let's see what that does. Some of them might have been outside of it. Yeah. I'm going to go back to the emitter, and we got our width and our height, and I'm going to shrink that down. Scoot our letter backwards, and now hit play again. So they should be trapped. Now, they are traveling quite quickly, but they're doing a pretty good job of staying trapped, and you can see that fairly quickly this is filling a lot of the volume. It's not, they're not getting up here too well. Oh, the attractor is still on. The attractor's down here. Interesting. I didn't even think about that. If I turn off the attractor, then that should do a much better job of spreading out. There we go. I was wondering why they're clustering up so much. There was no reason for it. But now you can see they're just totally randomly bouncing around. And now we've got this disgusting kind of worm-filled or maybe spaghetti-filled ampersand. And we can let this fill up a little bit more maybe. And yeah, excellent. That looks great. And I can tell that to not render. And I can just go ahead and hit render there. Now we've got a very distinct letter, and all these lines are doing the best they can to avoid each other. If we were to shrink the radius of those a little bit, you can really get those nice lines twisting in, how much they're filled. Keep in mind that those are nice squiggles that aren't really intersecting each other, but those, we don't have to sweep it. Those could be sketch and tune lines. Those could be, we could actually be seeing the trail of particles as they fly around and leave a trail behind them. Like so many different things that this could be played with. Like it's just a cluster of particles avoiding where they have been. I'm trying to think if there's any other fancy ones. Like this was just sweeping the splines, and then what do you do? A spline wrap. I used a spline wrap. I made a really nice model of a pencil, and I did a spline wrap on it, and they're wrapped around the existing lines. This is pretty straightforward. Let's see if we can maybe make that. This is pretty cool. I'm going to save that file. Let's save another one. And jump on over to, let's just do a sphere, nice and straightforward. And I'm going to move it down to, actually, let's move it up to be right about where they're all going to emit. And it's going to be a little tricky to get the right the right setting. It might be good to get a radius. I don't know. We'll just have to play around. But let's just see if we can get it working. I'm going to steal this tag, put it over there, delete the text. And so these are all going to be attracted there. And I definitely want these particles attracted themselves. Definitely. And they definitely should repulse themselves. And let's just see what happens. Now, right now, there's going to be a big cluster of them. They're going to be pulling all over the place. So forces, maybe start accounting for more. Relatively small attraction radius. And no attractor, but the sphere, right now it's just collisions, of course, so now we need to turn on some attraction. I'm going to set it up to 25, which is pretty high, and let's hit play and see what happens. All right, they're definitely twisting around each other a lot, but they're not really traveling around this form. Why don't we drop our emitter down to emit just one particle? It's a little cleaner that way. And of course, the sphere is set to collide on the inside, so I have to set that back to turn on collision on the outside. Super important. Okay, it's definitely wanting to twist around itself a lot, which is largely this attractor. Oh, maybe we don't need, well, we want some attraction, but maybe very weak. And it's just shooting off into space. Why is it doing that? Well, it's doing that because, maybe because we have no repulsion. Okay, cool. Now we got some repulsion, which we need for the geometry to actually react. Very important point. And once again, I'm trying to recreate something that I spent a lot of time doing before. So now it's just really finding the right combination here, and I don't know what the combination is. Let's increase the attraction. Hit play. It's not attracted to itself very strongly yet, so I'm going to keep on cranking this number up until we get something. Sorta. Well, we're getting there. You see, it is attracted to itself now. So maybe our forces limit's going to be important now. Oh, look. Okay, so now we're starting to get there. Maybe it's not perfect, and we do have turbulence on, so let's turn that off. But what do we have going on now? Well, now it is attracted to its own tail, but it's more attracted to the surface of the sphere. So what's happening is we're getting this fairly nice spiral going around. It's not as clean as I would want it to be. Maybe our repulsion radius is a little too big. Let's slow that down. Set it to a smaller number. We're not quite getting a circle, even though we are getting this nice overall wrapping around. It's just tweaking and trying to find like this perfect combination of where the behavior is the way you want it to be. And I could go and open up. I actually brought them over. Like here is the actual file where I had it wrap around, and we could look at some of the super precise settings that I did. Let's see, where is it? Right there. So if I hit rewind and play, then we're going to get and start spiraling around. And you see, even there, it's not perfect, but then eventually it kind of settles itself down. And we can see here on my constraints on this one that we have a big attraction radius, very low. Well, 25 is actually pretty high. Like 25, you see I got that kind of same fall off going there. And then on the actual shape here, we have no bounce, lots of attraction, lots of repulsion actually. So I don't know. Once again, different sizes, different scales, different objects, different number of particles could change it. But that is the combination of settings I did for this to start spiraling around it. And because it's attracted to this object, it will eventually wrap around the entire thing. It does take a while. In fact, you see I have this is keyframed all the way up to 8,000 frames. It might take 8,000 frames for it to wrap all the way around this, which actually does take a while. And and you can see right now there's a little bit of repulsion with a certain distance from the surface, so it kind of rounds us out a little bit. But it does eventually make for a really neat shape. And of course, the radius is independent of that, so I can like shrink this radius way down where we get this nice little wire. But you can probably make some really cool wicker baskets, or just a lot of different things to be wrapping around this kind of shape. Super fun. And like obviously this was up to 55, and then it had like I don't remember what this was, but it was up to some higher number. Oh, okay. Well, that definitely immediately put it to more of a spiral, even though, well, no, not necessarily. But like, look at this. Okay, not the spiral, but that is a super interesting pattern. Now, eventually, it got sucked away and jumped up out of the air, which is too bad. And I wonder, yeah, we need some attraction, otherwise it's not going to wiggle. But we want it to be attracted to the surface a lot more. I don't know. Tough call. I don't know. They'll combine. I'm starting to ramble now because it's just really fun. I didn't spend hours playing with this. I spent weeks playing with all the different ways of combining and playing and messing around. Let's see. Do I have any files here that are different than what we've talked about? Like here's just some random geometry, and I told it to emit from the surface, and you see there's growing a whole bunch of vines all over the place and starting to wrap around them. Exact same stuff we've been talking about. Just emitting from the surface. This one slows down quite quickly because there's a lot of them. And you'll see there's probably quite a few polygons going on. And then, let's see, you saw that avoidance one. Here is just a setup I did for them to kind of twist around and head towards the center. We've already kind of played with and almost recreated that one perfectly, so we don't need to review that. I think this is just when I discovered them twisting around themselves. Here, where you can see they're kind of cluster and attracted to themselves, which is pretty neat. And then, I think this is one of the earliest files I got this technique working. I guess it's just kind of them wrapping around themselves, but it's like, holy cow, this is working, this is crazy. They're like, we got a bunch of snaky worm things avoiding each other and, pretty accurately wrapping around and being attracted to each other and moving around. It's crazy. There's so many cool things that could be done with this technique, from parametric vines to, growing your own vines, I guess are not parametric, but, and there is a little bit of a setup to this. Like, you can see right away that we had to do kind of, not a complex, but it required like all this stuff to work. But now the controls are really straightforward. And like I said, the important thing to keep in mind here is the push and pull of different settings here. The constraints are super important. But the radius here is just has such a big effect. The forces limit's kind of like this wild card variable of like how many particles around it should it be paying attention to. The fall off here has a lot to do with everything. Like we could probably make this fall off a lot bigger. This would be actually kind of an interesting experiment. If we were to turn off the sphere and emit a few more particles, we could actually try and have a very large radius. So there's a very large radius of avoiding. But what we could do is have it be quite low until it gets quite close. So what this is saying is like they won't be very close to each other, and they'll be like, yeah, like we're a little too close. I don't want to be this close, and slowly avoid each other. And then as they get closer and closer and closer, it'll suddenly get strong. So we could end up with, and we're going to need the attractor or something to kind of pull them in the same area. But they're in general, I guess our attractor is very strong. And our repulsion is a big radius, but it doesn't get strong until the end. I'm not sure why they're getting sucked into the zeroness of that. So maybe this radius just needs to be a little bigger. Well, I missed I mixed something up there. Is that just because? Oh, no, the attractor has to be smaller than the radius. Well, that's more like what I'm talking. I think the problem there, remember, I keep saying that the attraction has to be smaller than the radius, and it was actually accidentally the same size, and that could have been causing some big problems. Actually, I don't think we need any attraction for this particular setup. They're all avoiding each other with a very large radius, but they are being attracted to this point. So let's see. They are really taking some big old arcs to avoid each other. Anyway, I'm just playing. Now I'm just playing. I'm not even explaining things. I'm just tinkering around because it's so fun. So let's drop that down to like 25. So you see there's a larger radius where they're avoiding each other. And we should get some smoother avoiding as they get closer into those areas. And you see, like, yeah, with this larger radius, like, they're never getting that close to each other. Eventually, they might get forced in, and eventually it gets very strong. And I even wonder, like we probably want very, very low numbers on these until it suddenly shoots up. And before it's actually quite weak. So now it's actually quite weak, and they should be doing a very soft avoidance of each other until they get very close. Which does seem to be the case. Like they're very, look at that, see how they're splitting from here? Like these two are close to each other, and it's like this one's like, I think I'll go this way, and this one's like, I think I'll go that way. But when they get attracted back in, eventually it's like, oh no, gotta move away. Yeah, so like you've seen how to have these wrap around the outside. We've seen how to trap them on the inside. We've seen how to make these really cool coils. We've seen how to move the attractor around to different areas so you can kind of draw out this weird viney shape. You could actually have it be wrapping around a sphere, but then be using an attractor to be like, kind of move over this area. Okay, now kind of move over to this area. In addition to all these things, we could have these trails be limited. Like the trails could eventually erase out, and we could have the particle tail, the emitter tail, those could have a time limit. They could have a lifespan that's not all the way, and it could die eventually, and then like kind of their old paths would eventually fade away. I guess not fade away, they would just like snap out of its existence and be gone. Unfortunately, we can't use anything to, like these fall-offs are absolute. Like I can't use the radius of the particle. I have to use the radius of this global variable here. And if there was a setting here to do it on a bi-particle basis, we could actually do a lot more stuff with it. But that setting does not exist. To throw it out there, and I haven't even played around with a lot of this stuff. You could probably use some flocking where they get pulled into each other. I've played a little bit with the viscosity. In fact, you can do this a similar type of rig here, not using XP constraints, but using XP fluid, SPH. And you can do similar things, but it's just a lot slower calculation. And kind of stylistically, I like the controls of the XP constraints. So feel free to experiment with that. And you can get some slightly more fluid-like moving things. But because we're dealing with like a series of not that many particles, the fluids aren't very applicable, but it also kind of has an avoidance built in, and that's the key component here. It's these particles having a radius in which to avoid where they've been. I think that's going to have to wrap this one up. I guess I've rambled on long enough. Hopefully, I think the technique is really cool. It's really fun to use, and I think once you've got it figured out, like you can kind of artistically control it. So I'd love, like, put your links in here, tweet at me, put your links in the chat. The comments below of things you've made. Make things that I didn't make. Like I don't want to see your guys' version of a golden spiral. Make something I didn't think of. Make some beautiful vines growing up the side of the building. I have no idea. Like do some cool stuff. And I want to see it because this is a really cool technique, and I'm glad it's now out there in the world. So I'm gonna say goodbye for now, and I'll see you guys in another Grayscale Gorilla tutorial real soon. Bye bye, everybody.